Okay, some of the features of the Earth that make it unique is the fact that we have the right distance from the sun. There's a region around the sun, around any star, we call the habitable zone. If a planet's closer to the sun than this or farther away, then it's too warm on one hand, so that liquid water can't exist. Too far away, it's too cold. You get ice, you don't get liquid water. But that's just the beginning, because the moon is the same distance from the sun that the Earth is, and yet it's dead, it's lifeless. The problem there is it doesn't have an atmosphere, so it doesn't have liquid water. It lacks a lot of things, really. The composition's all wrong. So you have to have the right kind of composition for your body. There are a lot of trace elements, well, not trace really, but iron is one that we need for life, and yet iron's pretty rare on the moon, as it turns out, but it's pretty common on the Earth. Also, you have to have the right kind of atmosphere. That requires that you have appreciable gravity. The moon has too little gravity to hold on to an atmosphere, but many planets, such as Jupiter and the other large gas giant planets, have the wrong kind of atmosphere. Venus has the wrong kind of atmosphere. You need an atmosphere that's dominated by what we call a diatomic gas. These are two atoms that are bonded together. Oxygen, for the most part, O2, is what we breathe and live off of. That's a diatomic gas, but too much of that's not good because of combustion and other oxidation problems. Our atmosphere is ideal. It's about 78% nitrogen, N2. And the diatomic is important because polyatomic gases, there's three or more atoms together, such as CO2 and water, they produce what we call a greenhouse effect. And again, too much of a greenhouse effect is a bad thing, as you've probably heard with global warming and all this sort of stuff. And the Earth's atmosphere seems to be unique in that respect. In fact, so much so now, when they're looking for life on other planets, or maybe planets around other stars that could support life, one of the things they may look for is nitrogen-based atmospheres. They think they can pick that up spectroscopically. You have to be in the right part of the galaxy. If the galaxy is if you're too close to the center of the galaxy, you've got problems with the stars around you causing problems. Too far out, all sorts of things. So you have compositional differences within the galaxy. They're now beginning to think that there's a narrow range within our galaxy where life is possible. Having a good tilt on the Earth is good. We have a 23.5 degree tilt, which causes our seasons. Anybody familiar with the seasons is aware of this effect. A little less known is the fact that the Earth's moon stabilizes the Earth's rotation axis. If the moon were not there, then perturbations or little tweaks from other bodies, primarily the sun, would cause the tilt to go from 0 degrees down to 90 degrees and back again. And during these wild swings over thousands and thousands of years, you'd find that vast portions of the Earth would simultaneously be in the tropics and in the Arctic regions, which would be bizarre when you think about it. That would be disastrous for living creatures. Well, the Earth's moon, given its distance, its mass, and the kind of orbit it has a unique orbit of satellites in the solar system. It stabilizes the Earth's orbit to within about a 2-degree range. It can go back and forth, but no further. Now, as I said, you got to have the right size moon. It's the size that needs to be. It's massive compared to the Earth. It has only 1.6% the mass of the Earth, but usually the planets outmass their satellites by thousands and tens of thousands. But also large satellites in the solar system tend to orbit above the equator of the planets. The Earth's moon orbits in the same orbit we follow around the sun. No other satellite does that. We're like 160, 180 satellites in the solar system. None of them do that except for the moon. Why? Is that just a coincidence? Is that happenstance? That's a unique aspect of the Earth-Moon system as well. As far as the fundamental constants in the universe are, we have the attraction for the electrons to the nuclei, the atom, which give us the nuclear bonds that we have. It also makes carbon this very unique substance that can bond so many different ways with different elements to form what we call organic chemistry, which is essential for life. Without carbon, life is not possible. If you change the fundamental constants of nature just a little bit, then that would not be possible. We wouldn't be here. So we find a long list of these sorts of coincidences about the universe and about the Earth in particular that make life on Earth particularly conducive, in this universe conducive. And you have to ask yourself the question, as a scientist, just how many coincidences are you allowed to have before maybe, just maybe, these are not coincidences? And I'm talking about design here. We make these design inferences all the time about things. A man named Paley 200 years ago suggested that if you found a watch lying on the ground, you would understand very quickly. If you've never seen a watch, you'd still understand it's a piece of machinery that has a designer. And many people poo-poo that sort of argument. But we make that inference all the time. And I make the same inference about the Earth. I think that there's a very strong indication that there's an awful lot of coincidences here, which I think is better interpreted in terms of design rather than just a bunch of coincidences.